In today's data-driven world, we are constantly bombarded with information. From news headlines to social media feeds, from market reports to scientific discoveries, data surrounds us. But amidst this sea of numbers, how do we make sense of it all? How can we extract meaningful insights and draw informed conclusions? The answer lies in the fascinating world of statistics. Statistics is more than just a collection of numbers. It is a powerful tool for understanding and interpreting the world around us. It provides us with the framework to collect, analyze, and interpret data, enabling us to make informed decisions in the face of uncertainty. Whether we realize it or not, statistics plays a crucial role in our everyday lives. From predicting weather patterns to understanding consumer behavior, from developing life-saving drugs to optimizing business strategies, statistics empowers us to make sense of complex phenomena and navigate the complexities of our world. By grasping the fundamental principles of statistics, we unlock a new level of understanding and gain a valuable skill set applicable across a wide range of disciplines. This essay serves as an introductory guide to the world of statistics, demystifying its core concepts and highlighting its relevance in our daily lives. Join us as we embark on a journey to explore the power of data and discover how statistics can help us make informed decisions and unravel the mysteries of the world around us. Statistics is a branch of mathematics that deals with collecting, organizing, analyzing, interpreting, and presenting data. It is a way of making sense of the vast amounts of information that we encounter every day. By using statistical methods, we can identify patterns, trends, and relationships in data, which can help us to understand the world around us better. There are two main types of statistics: descriptive statistics and inferential statistics. Descriptive statistics is used to summarize and describe data. For example, we might use descriptive statistics to calculate the average height of students in a class or the percentage of people who voted in an election. Inferential statistics, on the other hand, is used to make inferences about a population based on a sample of data. For example, we might use inferential statistics to estimate the average income of all households in a city based on a sample of 1,000 households. Statistics is an essential tool for anyone who wants to understand the world around them. It is used in a wide variety of fields, including business, healthcare, education, and government. By understanding the basics of statistics, we can make more informed decisions in our personal and professional lives. For example, imagine that you are a manager of a company and you want to know how satisfied your employees are with their jobs. You could use a survey to collect data from your employees and then use descriptive statistics to calculate the average satisfaction score. You could also use inferential statistics to test whether there is a significant difference in satisfaction scores between different groups of employees, such as men and women or full-time and part-time employees. Statistics can be broadly categorized into two main branches: descriptive statistics and inferential statistics. While they serve different purposes, they are interconnected and complement each other in helping us understand data. Descriptive statistics, as the name suggests, aims to describe and summarize data in a meaningful and concise way. It deals with organizing, presenting, and analyzing data to reveal patterns, trends, and key characteristics. Imagine you have collected data on the ages of students in a class. Descriptive statistics would involve calculating measures like the average age, mean, the middle value when arranged in order, median, and the most frequent age, mode. It also includes visualizing data through graphs and charts to make it easier to grasp the overall distribution and patterns. On the other hand, inferential statistics takes it a step further by using sample data to make generalizations or predictions about a larger population. It deals with drawing conclusions and making inferences that go beyond the immediate data set. For instance, if we want to know the average height of all women in a country, it's impractical to measure every single individual. Instead, we can select a representative sample and use inferential statistics to estimate the average height of the entire population with a certain level of confidence. In essence, descriptive statistics paints a picture of what the data looks like, while inferential statistics uses that picture to make educated guesses about a larger group. They work hand in hand to provide a comprehensive understanding of data, enabling us to make informed decisions. Data is at the heart of statistics. It is the raw material that we collect, organize, analyze, and interpret to extract meaningful insights. In essence, data represents individual pieces of information that can be numerical, textual, or categorical. Numerical data, also known as quantitative data, deals with numbers and represents measurable quantities. For instance, the height of a person, the temperature of a room, or the number of cars in a parking lot are all examples of numerical data. We can perform mathematical operations on numerical data to calculate averages, ranges, and other statistical measures. On the other hand, categorical data, also known as qualitative data, represents characteristics or categories that are not measurable numerically. Examples include gender, male, female, eye color, blue, brown, green, or types of fruits, apple, banana, orange. While we cannot perform arithmetic operations on categorical data, we can still analyze it to identify frequencies, proportions, and relationships. Understanding the type of data we are dealing with is crucial for selecting appropriate statistical methods and interpreting the results accurately. For instance, calculating the average eye color would be meaningless, just as finding the median height would be inappropriate for categorical data. By recognizing the nature of our data, we can apply the right statistical techniques to unlock its hidden patterns and insights. Section 5. Organizing and displaying data, making sense of the numbers. Imagine you have a long list of numbers representing the scores of students on a test. Simply looking at the raw data might not tell you much. This is where organizing and displaying data comes in. It helps us make sense of the numbers and uncover hidden patterns. One common way to organize data is by creating frequency tables. These tables group data points into specific intervals or categories and show how often each interval or category occurs. For instance, we could group test scores into ranges, like 70 to 79 or 80 to 89, and count how many students fall into each range. This gives us a clearer picture of the score distribution. Visualizing data is another powerful tool. Graphs and charts allow us to represent data in a visual format, making it easier to grasp patterns, trends, and relationships. For example, a bar graph could be used to compare the number of students in each test score range, while a histogram could show the overall distribution of scores. Scatter plots are useful for visualizing the relationship between two numerical variables, like height and weight. By organizing and displaying data effectively, we can transform raw numbers into meaningful insights. It allows us to quickly identify trends, spot outliers, and communicate findings in a clear and engaging manner. This step is crucial for making informed decisions based on data-driven evidence. Section 6. Measures of central tendency. Finding the heart of the data. When dealing with a set of data, it's often helpful to find a single value that represents the typical or central value of the entire data set. This is where measures of central tendency come in. They provide us with a way to summarize data and get a sense of the average value. The three most common measures of central tendency are the mean, median, and mode. The mean is simply the average of all the values in a data set. It's calculated by adding up all the values and dividing by the total number of values. The median, on the other hand, represents the middle value when the data is arranged in order. It's less affected by extreme values or outliers compared to the mean. The mode is the value that appears most frequently in the data set. Each measure has its own strengths and weaknesses, and the choice of which one to use depends on the nature of the data and the questions we are trying to answer. For example, if the data is normally distributed, the mean is a good representation of the typical value. However, if the data is skewed or has outliers, the median might be a more appropriate measure. Understanding measures of central tendency allows us to quickly grasp the central value of a dataset. It's a fundamental concept in statistics that forms the basis for more complex analyses. Section 7. Probability, the language of chance. Probability is a fundamental concept in statistics that deals with the likelihood or chance of an event occurring. It's expressed as a number between 0 and 1, where 0 represents an impossible event and 1 represents a certain event. In everyday life, we often use probability intuitively. For example, if we toss a fair coin, we know that there's a 50% chance of getting heads and a 50% chance of getting tails. In statistics, we formalize this concept and use it to make predictions and draw inferences from data. Understanding probability allows us to quantify uncertainty and make informed decisions in situations where the outcome is not certain. For instance, in finance, probability theory is used to assess risks and make investment decisions. In healthcare, it's used to determine the effectiveness of new treatments. Probability is a vast and fascinating field with numerous applications. By grasping the basics of probability, we gain a valuable tool for understanding and navigating a world filled with uncertainty. Section 8. From Samples to Populations, Making Inferences with Confidence. One of the key goals of statistics is to make inferences about a population based on a sample of data. This process, known as statistical inference, allows us to draw conclusions about a larger group without having to collect data from every single individual. The key idea behind statistical inference is that a representative sample can provide valuable information about the population from which it was drawn. By analyzing the sample data, we can estimate population parameters, test hypotheses, and make predictions with a certain level of confidence. For example, suppose we want to estimate the average income of all households in a city. Instead of surveying every single household, we can select a random sample and use statistical inference to estimate the population mean income with a certain margin of error. Statistical inference relies on probability theory and sampling distributions to quantify uncertainty and provide a measure of confidence in our conclusions. It's an essential tool for making informed decisions based on limited data. Section 9. Conclusion Statistics, a powerful tool for understanding our world. In today's data-driven world, statistics has become an indispensable tool for understanding the world around us. From uncovering hidden patterns in data to making predictions about the future, statistics empowers us to make informed decisions and navigate the complexities of our increasingly complex world. Throughout this essay, we have explored the fundamental concepts of statistics, from descriptive statistics to inferential statistics, from data visualization to probability theory. We've seen how statistics can be used to summarize data, identify relationships, test hypotheses, and make predictions. By embracing the power of statistics, we unlock a new level of understanding and gain a valuable skill set applicable across a wide range of disciplines. Whether we are students, professionals, or simply curious individuals, a basic understanding of statistics is essential for navigating the challenges and opportunities of the 21st century. As we continue to generate and collect ever-increasing amounts of data, the importance of statistics will only continue to grow. By embracing the principles and techniques of statistics, we can harness the power of data to make informed decisions, solve complex problems, and create a better future for ourselves and generations to come.